Hey guys, welcome to your statistics lesson on quartiles and percentiles. So we are talking about first the first quartile, otherwise known as a lower quartile. And when you see the word quartile, hopefully it makes you think of quarters. And so quarters, you can either think of the fraction 1/4, or you can think of that as a percentage, 25%, so that it will help you understand that when you're talking about the first quartile, you're looking at 25%, and so that is where 25% of the group is either at or below. And for future reference, when we talk about quartile 1, we're just going to use Q and a little subscript of number 1. Now the second quartile is talking about where 50% of the group is at or below. And again, if you think quartiles, you're moving up by 25% each time. So that's how we got to 50. And we're going to represent quartile 2 with a capital Q and a little subscript number 2. When we get to the third quartile, if you add another 25%, you're up to 75%. So that's where 75% of the group is at or below. And you probably already know by now, we're going to call that Q3. Now, quartiles and percentiles go hand in hand. So when you see the word percentile, think about percentages. And when it tells you the nth percentile is the score where n% of the group is at or below, it goes along the same concept. So below you're going to see percentiles, because if they were quartiles, they'd be in increments of 25%. So the first, it says, use the cumulative frequency histogram to find the intervals that contain the following percentiles. So yesterday we talked about cumulative frequency, which is like that snowball effect, and it's adding over time and accumulating and getting larger. So if you look at this graph, right, first you notice, this might be a little new to you, right here, this little zigzag is what we call a break in the data. So this break is there so that we can make the jump from 0 to 30, wherever we want to start. So we can put that break on the x-axis or the y-axis, depending on if we want to jump one way or the other. And then it starts off with different intervals. So because this is a cumulative frequency, each interval is going to get larger and larger, and each interval, you'll notice, will always start with the same number when it's cumulative, and that number in this scenario is 30. So we have 30 to 34 interval, and there are 15 people in that group, okay? And then we have the 30 to 39 interval, and there are 41 people in that group, okay? But think about, the numbers are going to get larger because the intervals are also getting larger. So in the 30 to 44 range, there's 62 people, and so on and so forth. And the last number in the cumulative frequency table or graph or anything dealing with cumulative frequency, the last number will always represent what we call the total. And for the sake of giving this graph meaning, let's just make something up, and we'll talk and we'll say that this represents the ages of workers. So the ages are going to be represented in the x-axis, and the y-axis is the frequency, so the number of people in this scenario. Okay, so if we figure out the 80th percentile, right, so percentile, think percentage. So if we find 80%, then we're looking at that as a decimal. And so what you're going to do to figure out the interval that contains the 80th percentile is you're going to convert the percentage to a decimal and then multiply that number by the total. So if we convert 80% to a decimal, that's going to turn into 0.8 or 0.80. So remember, if you take 80%, 80 divided by 100, because all percents are out of 100, that's how you can get your decimal version, 0.80. And you're going to multiply that by the total. And the total, we said, was 120 people in this particular set of data. So when you multiply 0.80 by 120, you should end up with 96. And that tells you that this would be the 96th person from the bottom, counting from the bottom up, that we need to figure out what interval they would be in. So if we look, right, so we see the number 62. So we've hit up to 62 in that category, and then we jump all the way up to 100, which means that there are 100 people in the category of ages 30 to 49. And so 96 is going to fit in that category. So the interval that contains the 80th percentile would be the interval from age 30 to age 49. And then we'll find the 10th percentile. So the 10th percentile means that we're looking for where our 10% of the group is either at or below. So first we're going to take 10% and convert that to a decimal. So that should be 0.10. We're going to multiply that decimal by our total of 120. And we end up getting 12. So we need to look, where is the 12th person in this particular set of data? And looking at our graph, we see the first number is 15. So that means 15 people are in this category 30 to 34. So obviously the 12th person would also fall into that category. Now I'd like you to pause the video now to figure out question number 3 on your own. And hopefully you figured out that the 30th percentile would represent the interval from age 30 to 39, because that would be the 36th person in that group. Now we're moving on to quartiles. So the first quartile, Q1, is the same thing as asking you to find the 25th percentile, because the first quartile is talking about 25%, so where 25% of the data is at or below. And in order to do that, it's the same thing. We're going to take 0.25, convert 25% to a decimal, multiply it by the total 120, get our answer is 30, which is talking about the 30th person from the bottom. And to figure out what interval that is, we look at our graph, and we should be in the 30 to 39 interval range. So go ahead and pause the video now to see if you can answer questions 5 and 6. Okay, so hopefully you got the same answers for questions 5 and question 6. And when you get to question 7 and it says to find the median, otherwise known as the middle, if we remember that from yesterday, well, if we think about the middle as far as a percentage, that's going to be 50% would be the middle. Now, the 50% talks about the second quartile. So the median is the same thing as quartile 2. So question 5 and question 7 are asking for the same thing. So the important thing to remember here is that median and Q2 are the same. Okay, switching over to, I believe, what is page 8 in your packet, we're going to find the quartiles and any outliers that exist in a data by giving you a list of numbers. So first, there's a few vocab things we have to discuss. So we start off with interquartile range. And for future reference, we're not going to have to write the whole word interquartile and range. We're just going to use IQR to represent that. And the formula to find the interquartile range is going to take quartile 3 and subtract quartile 1. Now this is very similar to yesterday we talked about range. And range is always going to be the highest number minus the lowest number. And that's the same concept here. This is the highest quartile subtracting the lowest quartile. Now for outliers, we talked about this using logic the other day and just being able to spot an outlier, which is something that doesn't quite belong. It's either too high for the rest of the numbers or too low. But now I'm going to give you a formula that you can use to calculate and prove mathematically if it is in fact an outlier, rather than just using logic. So an outlier is technically any piece of data that is at least 1.5 times the interquartile range below Q1 or 1.5 times the interquartile range above Q3. And that sounds really strange to think about it like that, but we're going to be given these two formulas to figure them out for future reference. So you have an outlier if Q3 plus 1.5 times the interquartile range. If that number is greater than or equal to that, you have an outlier on the upper end of things, as opposed to if your number is smaller or equal to Q1 minus 1.5 times the interquartile range, then you have an outlier at the lower end of things. So we're going to push that off for now and just focus on the list of numbers below. In example 1, it tells you that there is an odd number of data, which means that one score is in the middle to find the median. Before you can do anything, you always want to make sure that your numbers are in order from low to high. So go ahead, pause the video, and rewrite this list of numbers across your paper from the smallest to the largest. Okay, once you have all of your numbers, a good way to make sure that you have all of them listed, because it's easy to forget one, is to count your numbers in the data that they give you, and there should be 13. When you count your numbers, make sure that you also have 13. Now that they're in order, and there are 13 numbers total, then we have one middle number. So go ahead and figure out what that one number is and circle it. And hopefully you circled 22. And you can tell that that's your one middle number because there are 6 numbers to the left of 22 and 6 numbers to the right. And that's what you're going to do next, is you're going to put brackets around the numbers that you haven't used yet. So the 6 numbers to the left and the 6 numbers to the right. Now, what we did find right now is 22 is going to be our median. And if we remember from a few minutes ago, that means that it's also quartile 2. Now we're going to find the other two quartiles, quartile 1 and quartile 3. Now quartile 1, also known as the 25th percentile, is going to be the middle number in the first group that you sectioned off. So, over to the left, you should have 6 numbers in that left category, which means that there are 2 middle numbers because 6 is even. And you're going to circle those 2 middle numbers. So you're going to circle 15 and 15. Now, quartile 1 is the number in between those, and since 15 is the same number written twice, you're just going to write down that Q1 is also 15. Now you're going to do the same thing in the other set of data, the upper set of data that you put brackets around to find Q3. So Q3 is going to be the middle number of this group. So if you circle your two middle terms, because again, you have 6 numbers in this group, so since 6 is even, you'll have two middle numbers. And this is just a coincidence that they happen to also be the same number. So Q3 is going to be 32. Okay, so we have all 3 of our quartiles. We have quartile 1 is 15, quartile 2 is 22, and quartile 3 is 32. Now we can find our inner quartile range. So to find our inner quartile range, we're going to take Q3, which is 32, and we are going to subtract Q1, which is 15, and we end up with 17 is our inner quartile range. Okay, the other things that we're going to eventually get into is the lower extreme and the upper extreme. So the lower extreme is the lowest number of your list, which is 12. So we can just label that LE for lower extreme. The upper extreme is going to be the largest number in our list. So that's going to be 60, and we can label that UE for upper extreme. Now the normal range is always going to be the highest number minus the lowest number. So the upper extreme, 60, minus the lower extreme, 12. And so our range is going to be 48. Now you might want to pause the video now because I have to go to a blank page so that we can then figure out if there is any outliers. Okay, so we are going to do 2 outliers tests to figure out if we have a lower or upper outlier. That means if we have a number that is either too low to fit in with the rest of the data or too high. So we're going to do the lower one first, and we'll write down the formula that we're looking at. So the lower outlier test says that you have an outlier if that number is less than or equal to Q1, quartile 1, minus 1.5 times the inner quartile range. So for the lower test, you're going to test the lowest number in your list, which the lowest number in our list of data was 12. So we're wondering, is 12 less than or equal to, quartile 1 is 15 in this scenario, minus 1.5 times our inner quartile range we figured out was 17. And now we can type this whole thing in at once. 15 minus 1.5 times 17. And when we do that, we end up with negative 10.5. Now, 12 is not less than or equal to negative 10.5. So since this is a false statement, that means that 12 is not an outlier. So we can write no lower outlier. Now for the upper outlier test. The upper outlier test starts with the formula that there's going to be an outlier if that number is greater than or equal to, this time Q3 plus 1.5 times the inner quartile range. So the two formulas are very similar. The only difference is less than or equal to versus greater than or equal to, Q1 versus Q3, and subtraction versus addition. So, the largest number in our list that we would be testing would be the number 60, and we're wondering, is 60 greater than or equal to Q3, which we determined was 32, plus 1.5 times our interquartile range, which again we found to be 17. So now I'm going to type into my calculator 32 plus 1.5 times 17 and hit enter to figure out what that number is. And when I do that, I end up with 60 is greater than or equal to, I ended up with 57.5. Now 60 is in fact greater than or equal to 57.5. This is true. So because this is true, that means that 60 is in fact an outlier. So we are going to do these 3 dots in a triangle formation, which hopefully remember means therefore, and we're going to say therefore 60 is an outlier. So we do have an upper outlier, and that is 60. 60 is definitely way too big compared to the rest of these numbers. And if you need to pause the video now to write down any of this information, go ahead and do so before we jump to our last example, number 2. Okay, here's question 2. Now, question 2 says an even number of data means that 2 scores are in the middle. Average them to find the median. Luckily, if we look, it seems that our numbers are listed in order for us already, from lowest to highest, and sometimes this happens, which saves us a step, so that's nice. So now what we should do is we should count the numbers that we have and figure out what 2 numbers are going to be in the middle. And if we've counted right, we should have 14 numbers. So half of 14 is 7. So that means that we're going to have 7 numbers and 7 numbers, and so the 2 middle numbers look like they're going to be this 43 and 48. And we need to figure out what's going to be that middle number between those 2. So, to figure that out, if you can't do it in your head, you're going to figure it out by finding the average, that middle number between those. You're going to take 43, add it to 48, divide it by 2, and that number, which turns into 45.5, is going to be Q2, your median. 45.5. Now, 43 and 48, although we circled those numbers, we just needed them to find Q2, but those numbers are not considered quartile 2, so we have to still include those numbers when we bracket off to find Q1 and Q3. So we are going to bracket these off accordingly so that we have the same amount of numbers in each bracket. We should have 7 and 7. Now, again, the first 7, when you find the middle number in the first set of numbers, that's going to be Q1. And since there are 7 numbers, which 7 is an odd, then there's only going to be one middle term. And that middle term we're going to circle should be 34, because we have 3 to the left, 3 to the right. So this is Q1. So Q1 is 34. Q3 we're going to find by finding the middle term in the second set of brackets, the upper set, and that number looks like 52. Because again, there are 3 numbers to the left, 3 numbers to the right, and so that's our third quartile. So we have all three quartiles. We need to figure out what is our interquartile range. And again, to find the interquartile range, you're going to take your largest quartile, Q3, and subtract your smallest quartile, Q1. So those numbers are going to be 52 minus 34, and our interquartile range is going to be 18. Now we can also figure out the normal range. So the normal range is going to be the upper extreme minus the lower extreme. So the upper extreme is going to be the largest number in our list, so that's going to be 66. The lower extreme is going to be the smallest number in our list, which is 20. So if we subtract those, we're going to have 66 minus 20, and that means that our range is going to equal 46. And the last thing that we're going to do is find out if there are any outliers, and we're going to use the formulas that were given at the top of our paper. So we'll start with the lower outlier, and that formula is the fact that we'll have an outlier if that number is less than or equal to Q1 minus 1.5 times the interquartile range. So the number that we're going to be checking is going to be the smallest number in our list, 20. So we're wondering, is 20 less than or equal to Q1, which we figured out was 34, minus 1.5 times our interquartile range, 18. And when we type that into our calculator, we end up with 20. Oops, I put that on the wrong side. So we have 20 over here is less than or equal to 7, and 20 is not less than or equal to 7, so that's false. So we know that there's no outliers down below, so now let's figure out if there's going to be an outlier in the upper end. And that formula is telling us that we have an outlier if that number is greater than or equal to Q3 plus 1.5 times our interquartile range. So the number that we will be checking will be 66, because that is the largest number in our list. So we're wondering, is 66 greater than or equal to Q3, which we figured out was 52, plus 1.5 times our interquartile range of 18. So we're going to type that into our calculator, and we end up with 66 greater than or equal to 79, which is also false. So because we have two false outlier checks, therefore, so remember the three dots represent therefore, if you put them in the shape of a triangle, therefore there are no outliers. And that is going to conclude our notes for today.